Hello everyone, welcome to Chemizon Complete Chemistry. So in today's video, we are going to solve question 41 of the GATE 2022 chemistry paper, which is based on a name reaction that is called Favorsky rearrangement. Now, how did I come to know whether it is Favorsky rearrangement or not? So it is seen in compounds that is alpha haloketones. So you will see alpha haloketones is an intermediate product. Okay, so this is the reaction. The major product M and N in the reaction sequence are. So there are two products. One is the intermediate product M and the final product N that we have to identify. So let us first draw the structure of the reactant. This is which functional group is given ketone. Okay, at the para position we have ethyl group. Now first we have to react it with NaH. Now what is NaH? Sodium hydride. Okay, it is Na plus H minus. It is a good base. Is a very good base. Why? Because H minus, if it picks up H plus ion, it forms stable hydrogen gas. So now, which is the acidic proton? We know alpha hydrogens are the acidic proton. Why? Because the conjugate base, okay, after removal of this, let's say negative charge is formed here, that will be stabilized by resonance with the carbonyl group. So that is why these hydrogens are acidic. Okay, so we can abstract any one of the hydrogens, both are symmetrical. Okay, so we can abstract any one of the hydrogen ions like this and form the conjugate base negative, and here at the para position we have ethyl. Now we have to react it with this compound MEO2CO. What is the meaning of this? CO means it is carbonyl. Okay, it is the condensed formula that is given to us. OMe, OMe. This is what? This is an ester of carbonic acid, H2CO3. What is the structure of H2CO3? Like this. This is the structure of H2CO3. This is the ester of H2CO3. This carbonic acid is reacted with methanol to get this ester. So what will happen? How this reaction takes place? This is delta plus, this is more electronegative delta minus. This will attack here and this will open up. So what we will get is this double bond O becomes single bond O, negative charge. Okay, a bond is formed between this carbon and this carbon. What is the next step? Next step will be this will come here, and O minus is a good leaving group. So it will go away as a good leaving group. So what we get is the product that we get is C double bond O ET. Here we have C double bond O OMe. Okay, this was the first step. Benzene is the solvent. Now B, now we have to react it with two equivalents of Br2. Now what will happen is NaH, it is already present in the system, right? It is already present in the system. So what will happen? It will abstract any two hydrogens. So which is the acidic hydrogen? There are three options. First of all, this will be acidic because negative charge is stabilized by two carbonyl groups. Okay. And another from where it will pick from the other side here. This is also acidic because it is stabilized by this carbonyl group. So both these hydrogens will be abstracted by H minus like this, and here also it will be abstracted. So we get two conjugate bases. C double bond O OMe, negative charge is formed here. C double bond O, negative charge ET. Okay, here at the para position we have ethyl. Now what will happen? This negative charge will react with two bromine atoms. Okay, it will undergo substitution reaction. This will attack. Br minus will go away as a good leaving group. Similarly, here also it will go away as a good leaving group. What we will get is para position ethyl, C double bond O, C double bond O OMe. Here we have Br, and then here we have Br. Okay, and there is one hydrogen. Okay, so second step is completed. Et2O is what? Diethyl ether, that is a solvent. Now the C step is what? C step is reaction of this substrate with a strong base. Okay, NaOMe is what? It is a good base. So what will happen is OMe minus, this will abstract this proton, okay, and will get a conjugate base. Okay, let me draw the conjugate base. Now this conjugate base will attack here and Br will go away as a good leaving group. Okay, so what we will get, I can write here. Okay, so what I will get is, the next product that I'm going to get is para position. I have ethyl, 3-membered ring is formed, C double bond O. Okay, C double bond O, OMe. This is the next product that I've got. Here one Br is already present. Okay, so now what will happen is, the next step is what we do, O minus OMe. Now this will act as a nucleophile. Okay, initially it acted as a base, now it will act as a nucleophile. It will attack ketone. Now there are two options. Now the question is, why it attacked only ketone and not the ester? Because ester is what? Ester is electron rich. This carbonyl carbon is electron rich. Okay, but this nucleophile, it generally attacks the electron deficient carbonyl carbon. This is more reactive because it is more electrophilic. Okay, we know ketone, carbonyl carbon of ketone is more electrophilic. So this will attack, this will open up. What we will get is Br, C double bond O, OMe, carbon, negative charge, and here we have OMe. Okay, and then Br like this. Now the next step will be, this O minus will come back. Okay, sorry. So this carbon is a part of this. So this will be O minus OMe like this. So now the next step is, this O minus will come back and any one of these bonds will break. Okay, so that we have to check now, which is most stable. Let's say this is A and this is B. So let me first break this A bond. Okay, if I break this A bond, is it stable? Yes, because it is stabilized by the resonance. Now suppose if I break B bond, I will show it by orange. Okay, I break B bond and I will get negative charge here. Is this more stable, orange carbon ion or red one? Now orange one is less stable. Why? Because this will be stabilized only by inductive effect, and here it is stabilized by minus R, that is resonance. Okay, and we know that resonance is more dominant over hyperconjugation and then inductive effect. This is the order of stability. So resonance is more dominant. So the red one will take place. That is, which bond will be breaking? Let me draw again. Okay, here this was like this. So this bond will break. Okay, so what we get is negative charge here. This carbonyl carbon, this becomes C double bond O. Okay, so now this we have got this carbon, and now what is the next step? You can see Br is a good leaving group. So this will attack here and Br will go away as a good leaving group. So what is my intermediate product M? M is, there is this 5-membered ring. Here there is ethyl, double bond, C double bond O, OMe, C double bond O, OMe. Now you can see this is the product M. So if you see the options, if you have reached till this point correctly, then your answer is done. Okay, you can see there is only one option, option B, which has this intermediate M. Okay, rest all other options are incorrect. Now let us see this role of Dibal H. Okay, what is Dibal H? Dibal H is a reducing agent, and it also reduces just like LiAlH4, lithium aluminum hydride and sodium borohydride, by donating H minus ion, that is hydride donor. So what is Dibal H? If I want to write down the full form of dibyl H, what is it is? Dibyl H is di, I for iso, B for butyl, diisobutyl, Al is aluminium, and H is hydride. Okay, so if you see the structure of this, 1, 2, 3, 4. Okay, this is the isobutyl group. This is attached to aluminium like this. And there is one H. So this H minus is donated. This is the H minus that is going to be donated like this. So it is a hydride donor. Okay, aluminum can form 3 bonds. So it is a hydride donor. So what will happen? H minus will attack. This will open up. Okay, this will become O minus and bond is formed between carbon and hydrogen. This will open up and this will go away as a good living group, methoxide. So what we have got is aldehyde. So we know ester first get reduced to aldehyde. So similarly, this will also be reduced to aldehyde. But will the reaction stop here? No. Okay, reaction will not stop here. Another hydride ion will come. This will attack. Here also it will attack. And final product that we are going to get is primary alcohol, ET. Here we have CH2OH. And on the other side also we have CH2OH. Okay, so this is going to be the final product N. Okay, so what is the correct answer? You can see both the ester groups have been reduced to primary alcohol. So the correct answer is going to be option B. I hope you have understood the solution. The only important part was the first part that we had seen of abstracting the base, abstracting the acidic proton by the base. That is very important. You have to decide based on the stability of the conjugate base which is going to be more acidic and which is less acidic, and it is very important to take care of this ethyl group. Okay, this ethyl group is very important, that is added so that you can see the position of the ethyl group so that you can get the correct product. Okay, I hope you have understood the solution. Thank you.